Alrighty, I know it's been a while, but I'm back, and I'm doing some Inspire stuff today, because I am doing a presentation for Altair. I don't know, sometime in the next 2 weeks or so. So basically, to work on that, I'm just coming up with some thingies to do on a robot over here. So I was recently working on one of the gearboxes. As you can see here, I was defining gearbox contacts and then making a fully functioning gearbox over here. I tried doing a stress analysis with the design space that I defined, this guy, and we're trying to optimize it. Didn't work out because, well, later on I realized that the stress is not being transferred anywhere, when in reality, in the actual robot, it is, because here it's just floating and there it's connected to 2x1s. So I actually needed to put 2x1s here, here, and then on this side 2x1 going across this whole thing, and then put the brackets there and then fastener it, or create fasteners connecting it to the 2x1s like how it actually is on the robot. That way Altair would know how the stress is actually being transferred, because right now when I actually ran this, the entire part was reached way beyond yield, and well, that didn't really make sense. It was like in the 10 to the 13 pascals of von Mises stress, and I didn't understand why until now. So yeah, that's basically what I was working on. But now, instead of the gearbox, I'm going to do the carriage, because we actually need to do some weight savings on the carriage anyways. So I thought it would be cool to just do this guy first. So number one rule when you're doing FEA analysis and whatever is to strip the model of everything but what you need. Meaning, I don't need these motors. I don't need the belts either. I don't need a lot of things. Screws and stuff, get rid of them, right? So what I'm actually going to have to do, and I might just time-lapse this, or I'll just upload the whole thing, is I'm going to just include the third stage of the elevator and the carriage as the fourth stage, and then forget everything else, because I'm not defining how the elevator is actually going to move and stuff. I'm just defining what the carriage is going to be doing within one stage, right? So that's what I'm going to do right now. And then, yeah, I'm going to simplify all of this down to the pure basics, and then the plan is to analyze each part individually and then try to optimize it. So to start with that, I would need to, well, where is it? Pretty sure it's in the carriage. Yeah. I'm going to make a new carriage. New assembly, actually. I'm going to make a new carriage and call it FEA carriage. I'm still going to have all my plates and stuff here. It's just, so I'm still going to copy like most of this. Bring it in here. It would have been so much easier if I just duplicated it. I should have just done that. Ah, boy. But you know what? It's okay. The intake can go. Oh, there's way too many parts. Oh, what a mess. Where's the intake? Do we actually just combine everything in one? No way, dude. Oh, wait, no. Alright, duplicate. Delete this guy. In my copy, there should be intake. Yeah, delete. So I don't need the intake for the analysis of the carriage. Same with this guy, these guys and stuff. I just don't need them. Same with the bearings. You can go, you can go, you can also go. Your replicates can go. Every single screw on this can also go. I will define them myself later. Same with you. Spacers can be kept. Yeah, so basically this is the fun part of everything. Replicates go bye-bye. Same with you Krakens over here. You can go bye-bye too. I don't need to... This side I'll worry about later. For now though, I'm just going to try to keep everything here constrained up. What the heck? Interesting. There's a washer there, I'm assuming. Yeah, okay. I see what's going on. Revolute with this guy. If that doesn't work, I'm gonna lose it. Nope, we're good. Okay. And then you can go, you can also go. And then just planar with the spacers here. Cool. And then I'll delete the screws here. So that's the other side of the plate, and then I can keep these guys because they're not actually they're not crucial for this analysis, so it doesn't really matter. Yeah, the shafts all go and the collars too. Yeah, all of this is just a mess that I don't need. And the bearings. The bearings, those go. And these guys all go as well. Boop, boop. Yeah, you're good. I'm just trying to keep this all as simplified as possible. What did I do? No, I didn't. Yeah, you're going bye. No, I don't. I mean, the gear stays, but you go bye bye. What else? I think, yeah, that's it. Everything else can stay. Center block does not need to be there. Same with this guy. Yeah, we're good. So what I need to do next is bring in all the gears and then change them to circles, because Altair actually struggles with understanding what hex shafts are. So I actually have to just make them axles, so circular axles. I need to extend this out. This is a 50, 48. Alright, I'm just gonna bring them all in. 52. They're pocketed. Yes, so 52 and then 50, then a 48, and then a 60. 48, 60. 48 tooth, pocketed, and then a 60 tooth, also pocketed. 60, what do we have here? We have a 32, a 22, 32, 22, and then a 22 right here, and then there's one more, this guy, 54, okay, and I believe that's it. Oh, 54 and then this guy. And then a 10. So 54 and then a 10. Pocketed. Yeah. Yeah. I'm good. Oh man, that's annoying. Okay, well, I'm gonna hide this guy and then just, well, just go at it, I guess. Bum 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 bum.
Oh, I know what this is. I got shampoo.
We can do. I know what I need to do first. Merge with you guys. Yep, cool. So that creates the hole in the middle. 0.7 inches, and then go back here, and then extrude. Up to fit. Can I make it symmetric? Symmetric. Okay. 0.5. Okay. Cool. So I guess I just do that for everything. Add symmetric 0.5. Rinse and repeat. Symmetric 0.5. You're gonna merge with the 50. Add. Merge with the 50 over here. Cool. Same thing. Add symmetric 0.5. Merge with the 54. Cool. Extrude symmetric 0.5. Merge with the 60. Nice. So that gets us those guys, and then you over here, mister. We're gonna have some fun with you. I guess wait, this isn't centered at all. Now you are. Okay, so I'm going to make you 0.25, and then cool. Add up to face. Boom. So that gets me 0.25 on that. So those are all circles now. So now I have all of these guys to work with. So these guys are all now FEA worthy. So I go back to my carriage, paste all of these guys in, and then just start swapping them out one by one. Oh, I also do need to make these. So I go from here to here. That's 1.5 plus 0.25. Okay. So I'm making those axles now, and they can just be combined hubs. It's close enough. So what I mean by that is I can do 0.5. That was 0.5, right? Yeah. 1.5. No, 0.75 gets me to 1.5, right? Nope, that just means total. Okay, 1.5. cool. And then I'm going to add 1.125 over here. Extrude this guy out, 0.25. Nice. And then mirror. Cool. So that's axle number 1. Yeah, and then I just repeat that. Rinse and repeat for a lot of these guys. So you are a 50. All right. Where is my 50 boy? 54, 60, 50 over here. Cool. So you're going to revolute at the end over here, like that. 50, and you are a 22. 22 gets replaced with the 22 over here. Okay, let's keep going. You are a 48. So 48 gets replaced over here. What are you? 32 gets replaced. Same with the 60. So 60 and a 32. 60 over here. And a 32, which I believe is this guy. Yep. And then finally the 54 guy down here. And that's run by one motor, which I do have to make another part studio for. We can do the same 0.75 to 0.25 axle. 0.75, cool. Extrude 0.25, cool. Extrude 0.25, cool. Extrude out 0.5. All right. Boom. And then you can go bye-bye and replace it with this guy. Yeah, okay. So now I just have to set up the lining up thingy issues. Oh, I do have to do one more thing. Yeah, here, I'll do one at a time. So I'm going to make transparent, and I'm gonna just slowly start making the gear meshes work. So you can go over here, make transparent. You can also get transparent. Okay, so all right, cool. Cool. Oh, what the hell? Oh, whoa. Oh, 20. I totally forgot about the 20. Okay. Whoopsies. I didn't put the 20 in there. Shit. Okay. Why is there so many gears in this thing, man? I don't know why I'm complaining. I'm the one who designed it. Okay. Alright, you guys can all be hidden. You can merge with the 20 as well. Merge with the 20. Cool. Okay. And now another extrude off of this guy. 0.5 symmetric. Merge with that. Cool. Bring the 22 in here. Cool. Alright, so back to where I was. Hide. It's kind of a pain, and honestly it is, but it's so worth it in the end, because analysis is fun. I actually really enjoy it, so I think it's honestly worth it for all the tears that I put into this thing. Cool. So it's important to keep the gear meshing right, so I don't have any problems in Altair. So these should all be good. Alright, show all instances. We're good here. Hide. Okay. I think we're all good here. Oh, no. I forgot one more thing. I have to complete the axle over here. So, as in, this stretches across the whole thing. So what is the distance from here to here? 3.13. Alright, fine. Wait, is that inside to inside? It is, okay. So I need to go here, duplicate. Here, this guy. 3.13. Cool. Nice one. So if I do here and then replace, Part Studio 8, shit. It's this guy, right? Alright, cool. So that connects to this guy, and then from here onwards, go here to here. Man, some stupid ass numbers. Alright. You here, cool. God damn it. Extrude this guy, 0.25. Alright, so that gets us the hub for this thing. All good there. You're probably wondering why I didn't put the intake on here, and that's because I can just define it as a mass. So it shouldn't be too much of a problem. So I think I'm good. Yeah, I'm chilling right now, so oh, I do need to put the 2x1s in. Almost forgot. Elevator here. Insert assembly. Stage 0. No, stage 2. Yeah. So let me insert stage 2 in here, and then this guy is going to be grounded. Oh, where's the center block for this guy? Honestly, it doesn't really matter, but actually it does. So let's hide something. Show all instances. Whoa. The elevator is angled over here. Okay. I need the center block for this guy. No center block? Huh. Interesting. Okay. That's cool. Slider this to that. Solve. Nice. Cool. That's not how I would have wanted to do it, but honestly doesn't really matter. Now, will Altair have an issue with this? Because I'm just realizing this issue. Don't know. If there's anything I could do, it'd probably be to... Oh, it's just like barely intersecting. I don't know what I'm gonna do about that, honestly. Here, I'm gonna just leave it like this and then export it and see what happens. Where am I? Carriage? Yeah, okay. Export. Cool. Alright, exported, open. And let it do its thing. Alright, so I have it all in here. So first thing I want to do is, well, material. I'm gonna do the easy option and just go 6061 on everything, because for the most part it basically is all 6061, so that'll just save me a bit of time. And then I guess aesthetics, I suppose, color change. People would kill me for trying to do this, but honestly I don't really care. It's kind of funny. You turn into a blue. Something like that. Yeah, whatever. Honestly, it doesn't really matter. It's okay. I don't even know if this is even gonna work. Let's try... Okay. How am I going to do this? Let's start with rigid groups. We're doing a motion analysis, so let's start with the rigid groups. So I know my entire elevator boy, all of these guys. Oh, can I just not? Okay. Jeez. Alright, I actually have to select all of this. Man. You know what? Screws are screws. I probably don't need them anyways. That just becomes too much work for me. And I'm like, yeah, you know what, I'll pass. Delete. Down here, same story. Honestly, I can just delete the... I should have just deleted this in Onshape. Would have been easier, but it's okay. I could probably highlight everything and delete it. Yeah, as long as I keep the block here that defines the connection, and I just delete everything else. Yeah, just do same thing up here. Okay, we're good. So those are cool. Yeah, so my rigid group, you are all, same with you, and you. Yeah, so you are rigid group number 1. I'll just call it, stage 2. Cool. Alright, and now next is the carriage itself. So how do I do this? I think my next rigid group would be all of this. Go boom, boom, bang, bap, just all of this. It's like the connectors and stuff, so like it's not related to my simulation at all. So well, actually it is crucial to the simulation, it's just I don't think it matters. Oh, but I need to include this too then, yeah. No, but if it is, then no, I can't do that. Nope, I can't do that. I have to delete the screws and then just fasten them. I'll call all of this a rigid group, like that. I know what to do. You're a rigid group. You. Ah, god damn it. You. That's a rigid group. And you connect to the plate. Actually, you know what? Oh, I'm cooking now. Boy, I'm good. Yeah, I'm cooking. Because if I do this, and then I want the plate separate because I want to do an analysis on the plate itself, right? So I would separate the connectors on the outside from the plate itself. So I think what I'm doing is right. I mean, I'm no pro at this, but you know, I kind of sort of know what I'm doing. It's just slightly. So I'm just taking a gamble on this. You go like that. Cool. I do need to delete the nuts. Everything needs to be a rigid group, or else it'll just like fall off the face of this earth from gravity. Well, I'll enable it and then it'll just fall off. But okay, I think I'm good now. So I've defined my connections here. Yeah, I think I'm good. Cool. And then I can delete these guys. I want to see if the fasteners recognize it and then connect it together. Because what's next is, here, let's go to structure, fasteners. Oh my god. Oh my god, I love this thing. Oh my god, I love this thing so much. Yes, that's exactly what I need. You need to go through here. Yes, that's exactly what I need. Yep, so that connects together. I absolutely love you. This is amazing. You are not needed. I don't know why. Yeah, I'll put a joint there, so I don't need to do the fastener thing. Nut and bolt, for sure. You're not needed involved here. Cool. Yeah, cool. Yeah, you're good over there. Boom, 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 boom. Yeah, these connections are correct, so that's exactly how I wanted it to go. Cool. And then up here, same story. I did not need that grounded bolt. I don't know why that formed, but there you go. Cool, cool, cool. Nice. And then we just press OK. I know it created some extras, which I don't need. So U, delete. Yep. And then there's a grounded one right here. Yeah, delete. Alright, everything else is correct. So that should just connect everything together, honestly. These guys should just fall to their doom, if I had to guess. Oh, I do need to ground that. Sure, we'll just ground that piece. Let's see what happens. It should just fall right through the... Yeah, okay. Nice. It'll at least that works. So what's next is defining the contacts. Well, yeah, that might all be defined. So if I define contact between you, and you, and then motion should just... Oh, whoa, okay. That... What the heck? Oh, that is so cool. I don't know what happened there, but that was really cool. Oh shoot. Okay. Close. I think we're good. I don't know where I am. Okay. I'm gonna slow this down. Right. So these guys fall off because they are not connected in any way, shape, or form, but the rest are because they're fastened. So, which makes sense. Totally get that. Okay. I'm on the right track. So now I need to define my joints. Yes, right. So here we go. You are not joints. You are, though. So right here, you are a hinge. You are a hinge as well. Hinge, active hinge. Hinge. You're also a hinge. Boom. Boom. Hinge, hinge, hinge. What else right here? Hinge. 1, 2, 3, 4, 5. Yep. You are a hinge but locked. Same with... I did not need that, but okay. That pin is annoying the hell out of me. Alright, what else do I have? Locked. Cool. You are locked to... Same with you. Locked. I don't know why it's... What is going on here? There's so much crap going on here that I don't really understand. Okay, see, now it's all making sense. So it's just... I don't know why this guy over here is not... There you go. Oh, it's not recognizing this one. That's what I need this guy right here. Okay, this might work. Hinge locked. I'll see if that probably should work. It's a little bypass for what I'm trying to do. You are locked. You are locked. You are locked. Yeah, that should be everything. You are a hinge, you're active, you're also active. Cool. So up to 23, everything else can be deleted. So now if I do the same thing, right, okay, so now we have that. That is kind of funny though. Realistically, is that what would happen? No, but we can always fix that. So what's next is to create contacts between you, and you. Oh, and then you. This might be a problem. I already have a feeling that this is gonna be a problem. And then contact, new one, boop, 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 boop. No, not you. You. And then here, like that, create contact. Cool. So, I already have a feeling this is gonna be a problem. Yep, intersecting parts, that's gonna, like, the entire thing's gonna explode. If I had to guess. Or not. Oh, wow. Wait, that is surprisingly accurate. Well, not really. But you know what? That's actually pretty good. I thought it would be a lot worse. Okay. So now, let's start the fun, which is motor here. I'm spinning you at 60 RPM, and then I'm going to create contact between you and you. Cool. And then from you and you, like that, and then, wait, this one's going to spin this one, so it's going to spin, shoot, I can't even see right now. God damn it. Wait, what did I define context for this guy? So now it's you, and then you and you. If I go back to joints, yeah, that was locked. Good. So if I now, at least I believe the gear should be spinning now. It is going to take a lot longer now to analyze motion. Significantly longer, I think. Motion contexts are very resource intensive. Oh, cool. So everything is working. So this gearbox is actually working. Well, that's good to know. So that's cool. So we've got the working gearbox over here, and now I need to put the mass for the intake on here. So if I go to the intake somewhere over here, yeah, and then just get the mass of this guy, and then just offset it a bit from the center. I'll just from reference frame. Oh, make connector. Cool. I'm just gonna assume this guy's pretty much symmetrical, so I'm just gonna make connector for reference frame from you. I just want the X and Y. Yeah, I just want the X and Y. So you're going 0.314 and then 9 inches up. So structure, masses right here. And then I'm going to offset this guy. How much do you weigh again? Alright, we're doing 2.5 kg. 2.5 kgs. We'll do 3. Safety factor on that guy. And then we go out. Oh, we're in meters. Ew, we need to be in freedom units over here. 0.314 inches negative. Yo. Alright, 0.74 plus, I can't even do that. Alright. Alright, I'm guesstimating over here. X translate 0.314 inches. Oh, there we go. Cool. And then we go up 10 inches. Cool. So that's where the CG of this guy is. And then I need to put a connector from here to this axle. You are rigid. Cool. So now that represents the intake spinning. So if I actually play the motion analysis now, this gearbox should be struggling. Pretty sure. Well, let's see. Or the gearbox won't even turn it. One or the other. I don't know. Oh my god. Yeah, this is gonna just take significantly longer now. Because at that point where it hit the ground, it was calculated the momentum of this. Oh, yeah. Yeah. Oh, this is a lot of calculating it's doing. I mean, I have a pretty good PC, but still. It's really like... It's pretty resource intensive, so... Yeah, I'll just let it do its thing for a bit. So I'm just gonna pause the recording for a bit, because it only takes a bit of CPU power, but still, it's whatever. I'll come back to this when it's done loading everything. Okay, I'm back. I kind of took a break and kind of forgot about this, but it definitely finished a while ago. But I just came back a bit late. But this is basically what it cooked up, and well, as I figured, well, I can see that it is struggling to actually lift this thing. So one thing I could do is increase the RPM. Boop. Try that out. And then we'll see how this goes. Okay, so it's done, and let's see how this thing works. 600 RPM is definitely doing things. Honestly, I think that's good enough. I just kind of wanted to see what the stress is with this, which is what I'm going to check next. So I'm going to turn one of you guys into a design space. Design space you, and then we'll just analyze. one of these guys. It shouldn't take too long. Because, well, hopefully. From what I think, well, I actually have to do partition before I should have done partition before I analyzed it, but honestly, actually, no. I don't need to do a partition. Only when I'm optimizing it, that's when I do the partition, but then I have to oh my god. Oh, that's so annoying. I should have done partition before I did the motion analysis. Man, that's annoying. Okay, it's fine. I want to see what it cooks up. There shouldn't be a lot of stress on these guys. Because, well, there shouldn't be much. If anything, it would be... Actually, no. Wait, let me think. This guy wants to twist this way. So, actually, yeah, I think... No, there would be more stress on this guy still from... I think from the twisting motion, yeah, this would have more stress. Let's see what this guy has to offer. It displays... Oh, holy crap. Okay. I need to look at this from result envelope. Yep. Yeah, no, I get it. That totally makes sense. What I did forget to do is make this a rigid group. I did forget to do that, but okay. The fun stuff. Bro, where did you... What? What? Why? Actually, all of that does make sense, though, so... That does make sense, it's just I don't know why it's hitting yield. You know? Alright, let's do it with the motion load case. Okay, so right when we have impact. What goes on here? I don't know why it just does that sometimes. It just doesn't make sense to me. That's why it just seems to see the result envelope. So that's where it says all the stresses, which, yes, that does make sense. It's just the locations where the stresses make sense. I just don't get why yield is in their area, but you know what? That's okay. It does make sense. Let's optimize this though. I want to see what it cooks up. I'm just curious. This is not the right way to do this, but I just want to see what it comes up with. It would leave all the places with yield alone, but then it would just get rid of everything in blue. Or it would just fail. One or the other. So this thing's just gonna take a bit to load. It does some calculating and stuff. I guess I'll pause it and come back to it. So it's the next day, and I kind of realized last night that the intersecting issue was actually going to be an issue, so I kind of fixed that. So I just made this length just 0.01 longer, and now I don't have that intersecting issue anymore. Because fun fact, you can actually check in Onshape if stuff intersect. If you right click two things and click check interference, then it'll tell you if there's interference or not. So that's pretty cool. But anyways, I also colored the whole thing because I'm very confident that this will actually work. So So yeah, I forgot to define my context last time, so I feel like that might have also been an issue. And also, think I have a few screws left that I didn't delete. Yeah. Okay. So first thing to do is always to define context. So these are all bonded, right? You're bonded. You are, yes. So everything, all the bearings and stuff are sliding. See, like this thing, you're not bonded to the 2x1. You're actually sliding over here. So the first thing that I need to do is, well, define that. So you're sliding, you're also sliding here. You are sliding here. You're actually separating. Combining is not. Alright, sliding. Wait, what is separating versus sliding? Separating versus sliding. Inspire. Sliding with separation. If the relative parts can separate. I think these are actually separating, I believe. Yeah. I'm gonna define them as separating and redefine them later if that doesn't work out. Also, I'm curious what this guy is. Yeah, I don't know what that triangle boy is. I'm gonna assume separating over there. Alright, so next, yeah, so you are sliding, combining, sliding, alright. Then I guess everything is sliding then. We'll try that out for now. The inside of my bearing boys are... Oh, I need to define... I think I need to put fasteners in first before I continue. So I'm gonna just do that real quick. So you are none bolt. Cool. Yeah, actually for the most part, actually I think all of them are good except these two. So I'll just let Onshape do its thing, but delete these two right here. But everything else, it should auto-define for me. Should work out just fine, honestly. Yeah. Onshape does a pretty, Altair does a pretty good job at this. But yeah, okay. If I go back to context now, okay, fine. Sliding. You are... Alright, let's see. Sliding. You are sliding. You guys are sliding. Let's go high resolution so I can actually see what's going on here. Can I just like highlight everything and just go high? I mean, it's gonna slow the crap down of my PC, but I kinda need to see everything. So yeah, let's. Oh no, no, don't do that. Don't do that to me. Okay. You're bonded. Same with you. You're bonded. There's no reason for you guys to be sliding. Same with you guys here. You're just bonded. Same with you boys up here. You boys good? Yep, cool. Alright. You're bonded. Sliding, sliding, sliding. Yes, yes, those are correct. You are... What is going on here? You are sliding. Same with you over here. Sliding. Sliding and sliding. Yeah, all of this entire guy over here is... Oh, shoot. Can I get to it? There, sliding. Oh, I can't even, like... Ooh, that's tricky. Sliding. There you go. What's going on here? Ooh, I am struggling to access some of these. Oh, shoot. I think I need to hide a few parts to get there. Yeah, so you are sliding. Nope. You sliding. Same over here. You're also sliding. Cool. Alright, let's show all the parts again. Hide all parts. Show all parts. Alright, let's go back to my contacts. So you are all... This is all good. Right. Okay. So that's good. Let's just move up the chain now. So these circles are just meant to represent bearings. So yes, you guys all will be sliding. Sliding, sliding. The gears themselves are indeed bonded to the actual pole or whatever. So I guess the axle, right? So because we assume it's a hex. Oh wait, please don't tell me there's... Is there some... Just gonna... I'll just do no contact. There's not supposed to be anything there. Alright, let's see. What you are bonded. So defining context is fun. It's a bit time consuming, but definitely worth it in the end if you want to get accurate results on everything. Yeah, I don't know what's going on here. You should not exist. What's going on here? Sliding. You're bonded there. You're sliding here. Yeah, you're bonded to the middle there. Cool. Slide. Sliding. Sliding. Yeah. Okay. And then same over here. You guys are all no contact. Don't know why I even highlighted that in the first place. Bonded, sliding. There's just little pockets. Do I have to do these too, man? Seriously? Alright. It's alright. I'm so happy like I simplify the model down, because if you don't, you're gonna have that this thing is gonna give you hell. And I mean that in like the nicest way possible. This thing is it's gonna be terrible. Yeah, no contact there, no contact. Bonded. You are sliding on the side. Same here. Bonded. You are all set here. Okay, so these gears are good to go. So back down here, I need to settle the score with this thing, which I can just honestly, if I just highlight everything, go sliding, but then change this guy to bonded, then it just is correct, because everything else is sliding. No, I will say this washer. Yeah, I'll give you a bonded. Yeah, alright. Same story up here. Yeah, just... It's kind of fun. Up to a point, I guess. All of you guys just... Now that's interesting. Bonded. Oh yeah, actually yeah, only half of it is bonded. Yeah, that makes sense. You are also bonded here and here. You are bonded here and here. Cool. I think we're good. Those are all the contacts defined. Look at that, it looks like the U of M colors. But, yeah, okay. I think those are all the contacts defined. For that, alright, and now I'm gonna just hit this with a save real quick, because I've had some bad experiences with crashing. It just happens when I don't want it to. But let's do joints now. It's not really that good with joints. Like, I don't need joints there, man. Or here. I don't really get all that. But yes, there should be a joint here. A hinge. That makes sense. Hinge. Because that's an axle that's free spinning, so yes, that makes sense. I'm just making everything a hinge because I actually don't know what... It just seems to work best, honestly. Active. No, you're locked. That thing's right. Onshape is right. I meant... Oh my god, Altair's right. Hinge over here. Hinge. You are also active. So there's a fun fact here that if you used hex shafts instead of circles, it just wouldn't recognize it. Which is why I had to simplify everything down. But yeah. Here, you're locked. You're also locked as a hinge. You are nothing. Locked. You are active. Yep. And then you're locked. I don't know why it does that offsetting there, but it's okay. Locked. Hinge. You are locked as well. Don't need that. You are hinge. Active. Active. Actually, let me search this up. Inspire joints. Hmm. So I think it should be free then. So you're just free, I'm assuming. I think that's what needs to happen here. And then cylindrical pairs. I guess I'll make this cylindrical like it wanted to. It might actually be correct, so I'm just gonna stick with that. Free, you're free as well, you're free. I don't think that pin's gonna do anything, but I'll try it out and see what happens. Cylindrical, cylindrical. Anything else I am missing by perchance? You guys are all defined, so we're good. Cylindrical, cylindrical, cylindrical there. Oh, over here. Hinge, boom, boom. And we've got... I need to change these up. You're cylindrical. Okay. So I think that's everything. Everything else can go to hell, because I don't really care about anything else here. So after 33, everything else is... I don't care. So the rest can go. Cool. So now let's... oh wait, I should have done rigid groups first. Okay, that's fine. So this is the stage. This is stage 2 rigid group, and then my next rigid group. Honestly, I don't think I need any other rigid groups because, well, it should just all work. Let's just wing it and see what happens. Okay. Good to know. And also, what is going on there? Oh, is that... I see. Well, now at least everything should fall with it. Nice. Alright. So, I forgot to ground some stuff. You are grounded. Cool. Let's see. I think let's define contacts. We could do that, but it seems like these guys are not connected to this. And how do I fix that? Oh, I think it was in the joints, but I did do that, so maybe it's locked that I have to do. Okay, let's do this. Contact between here and here and here. Cool. Let's see how that works out. Yeah, okay. Alright, so good times. So this thing wants to somehow... What the heck is going on here? So this guy is okay for some reason, but the rest aren't. So I think locked is what I do have to do, actually. I'm gonna just delete this pin. Yeah, so the locked one seems to work, so we'll just make everything locked. hinge. Free. What are you? Oh yeah, you are to be locked as well. So you keep going. I think we're good. So if I run the same thing again, they should all just stay there, I believe. Cool. Okay. Next, define my next. I'll just define the connector contacts over here. You guys are what keeps this guy at bay. So all good there. Create contact. And then I'll go here. Contacts are fun, I will say that. Boop, boop, boop. And then you contact with this. Cool. Alright, so we don't have that intersecting problem anymore. So I think the force should be a lot less. And this doesn't really seem accurate, honestly. I need to figure out why, though. That's not supposed to happen, and oh my god, I know why. Why is it bouncy? But why is it bouncy? I think it has something to do with. Oh, I do need to enable friction. That might be what's going on. I don't know the coefficients of friction, honestly, but it doesn't really matter. That should make it lose energy. Right, okay. So the reason it was bouncing like that was because there's no loss of energy, conservation of energy, right? So now that we enabled friction, now it actually lost its energy, so that's how we. Okay, that makes more sense. Though that bouncing should not exist, but it's okay. Alright, next is actually linking all of this up. Jeez, alright. Cool. You're running at 300, let's do 3000 RPM. Or like 1800. I figure it's gonna be something like that. And then structure, mass, right here. You're going to be offset a bit. And then you're going like somewhere up here. Very sciencey. I think that's 3 kgs. Cool. And then you're connected from here to there. You are rigid. Cool. Alright, so let's run the motion again. This is gonna take a while, honestly. So I guess I just let it run. Yeah, I'm just gonna pause it while it does its thing. Alrighty, so I did some stuff off cam. Well, I kind of forgot to define the context for the gear meshing, but you know what? It all works now. So basically, this is what it comes up with. I don't know why this motor is going mentally ill. Well, this motor is going crazy right now, and don't really know why some things are doing some things, but you know what? It's okay. It's okay. I think it all looks like it's working. So here's what I'm going to do. I'm going to analyze one of these parts, and I pray it's actually going to work. So it better, or I'm going to be very sad, because at this point I don't know what else I can change, except maybe the context. I can change them to separating, though that means all the yellow has to be separating then, and that would suck. Changing all that would suck. But yeah, we'll see what happens. Okay, analysis done. Let's see how this guy worked out. Displacement. Looks okay. Alrighty. Looks about right, I think. Damn it. Oh shoot, I didn't define material. Oh my god, I didn't do the materials. Oh, damn it. Damn it. Oh, wait. Wait. The stress remains the same even if... Okay. Hold on. Okay, wait. So this is what it cooked up, huh? I'm surprised that there's this much stress in this thing. It just doesn't make sense to me. I mean, the places where it's showing stress do make sense. I totally get that. Yeah, okay. Though I do need to, I'm gonna redefine everything. Oh, I should have done this earlier. That sucks. It's all steel and stuff. Man, it's gotta be aluminum 6061. Oh, shoot. Oh, man. Oh, I can't even change the damn materials. Material. Oh, I have to rerun it again. That's unfortunate. Oh well. Guys, I freaking did it. I'm actually crazy. Oh my god, I'm actually him. It actually works. Oh my god. It actually freaking works. The places where I know there's going to be a lot of stress is exactly where the stress is for the plate. Oh, that's actually that's an achievement. That is beautiful, honestly. So if you come and look here, you can see that first of all the stress is on all the joints or all the connectors, right? So I expect, because if you look at the movement of hold on. I just want to see if, yeah, okay. So there's a constant torque force here, right? And along with that, that torque force is trying to twist this entire carriage this way, right? Since it's spinning like this, so it tried to twist the carriage this way. But what's preventing that are these bearings, this guy and this guy in particular, is what's preventing that twist force. So actually, if I do analysis on these bearings, you'll see the bulk of the loader is going to be on these guys. And then the reason why we have, let's go back to von Mises stress, and you can see that, right, the stress is at the joints, because since this plate is twisting, whatever is connecting to this plate is going to be stressed with it. So I would expect more stress on this side than on this one, which is correct, right? So I'm going to, oh, it all works. Oh my god, it all works. This is amazing. This is beautiful. Yep. This was a successful analysis because I actually agree with the data that's being presented to me. So this is actually really good. So that is a successful analysis. Now, I'm not done yet because I did this analysis as like a test, right? But now I need to actually optimize the part, right? So the first thing to do is to actually partition. I should have done this earlier, but here, I'm going to save this. I'm going to save this and, well, let it save. It's doing its thing. It's probably saving all the analysis data too. It's pretty hefty, but I'm letting it do its thing. Ooh, it's taking a bit of time to save, but should get through that. So I guess I can talk about it right now. So instead of, after you analyze the part, you can go straight into optimization, but the problem is if I do that, it's just going to get rid of so many of these holes and stuff, because if you checked out the analysis, you can see that Altair is basically saying, oh, well, you don't need any of the mass here, here, or here because all the stress is on the joints or the connections, right? Which is true. Yes, that's exactly where the stress is. So I need to tell Altair that no, I make a optimized part with connections to these holes and stuff. So that's what I need to do next. So I need to go to structure. Oh, I have to reanalyze everything. Man, that's a pain, but I'll do it. Let's go to structure, or no, geometry, and then just partition. Isolate. I'm gonna work on this guy now. So there's a cool feature called partition, and I'll just let it auto partition. It usually does a good job. Do I need that? Yes, I do. Actually, no, I don't. Ah, shoot. No, you didn't. No. Ah, okay. Alright, we're good. This guy's fine. I just need to partition the circles themselves. I'm just going to do that for all of these guys. Boom, 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 boom. Hello. Boom. And then up here with these guys. And down here. So by doing this, I'm basically telling Altair that you can mess around with everything else here except these holes. I want these to remain connected. So once I do the partitioning there, now I just need to, what the heck? Oh, whoa, okay, hold on. Oh man, I don't know why I did that actually. Here, I'm gonna hide. Oh, because it's countersunk. Yes, totally forgot. Yeah, these holes were countersunk. I should have probably. Yeah, I can. Yeah, so it. Thank God, it actually automatically defines the countersunks for me, so that's good. That's actually very handy. So we've got this going here. So those are all partitioned. So Now what happens if I hide these guys? You'll notice that it's separated from the actual bracket now. So here, I'm gonna show all of these guys again. So now what I have to do is go back to context and then redefine those. Those are all bonded now. Right, cool. And I think I still need to treat it as a rigid group. So you guys are still all a plate. Right. So you're still remain a rigid group, it's just I just partitioned it. So now if I go back here, I'm probably gonna have a lot of problems. If I'm gonna be very sad if, yeah, okay. I have to redefine everything. That's unfortunate. Actually, while I'm at it, I will also partition this guy too. Isolate. I will do the same thing over here as well. 0.03. I want to optimize both of these parts, so we'll do that. Cool. So that's good, and now I just go back to show all parts. Oh no, you're a rigid group. Motion rigid group. Cool. Oh wait, I don't think it. No, I think it forgot about this too. Nope. I meant to go back here. Rigid group. No, stop making a new one. No, wait. Rigid groups. There you go. So now that's part of that. So we have all of those now. Show all. Can I do a show all over here? Hide all parts. Okay, that just showed all of them. Weird. Okay, so. Oh, it's really bright outside. Okay. So now that I have these. Oh, I have to redefine my fasteners too. Man. Okay. Yeah, I guess I'll get a move on that. Also, what the heck? Oh, never mind. Okay, so let's go back to my fasteners over here. Find. Yeah, we're gonna have to redefine you guys, which Altair does a pretty good job at anyways. So, boom. I won't need one here, or there's one more right there. Yeah, so those two can be deleted. The rest can stay. That was pretty good. And then what I have next is to just redo the context for everything. So these are all bonded, and then everything up here, if I just highlight everything, make it all sliding, because most of it is sliding except the insides of these, and these are no contact over here. Oh, I didn't. Let me increase the resolution. Oh, bonded up here. You guys can go high. Let it load. Now it's doing its thing. Alright, cool. Oh, I also need to, here, I'm gonna highlight these. Sliding. Okay. So you're bonded. Kind of just undid some work there, but It's okay. No contact. Boom, boom. Alright, so you're bonded here. You're sliding there, bonded. Because remember, the partitions themselves are still part of the plate. It just, you know, I'm just doing it to make this all a design space. So it's still the same concept. It's just, I'm losing my thought right now. But okay. What is this? You are bonded, right? Yeah. Okay. I don't know why it's. Oh yeah. I get that. Cool. Sliding. You are also bonded here. That was a partition, which is why it shows that there now. Bonded. Sliding, sliding, sliding. No contact, all of this right here. Yep, sliding, sliding. Bonded right there. You're bonded. What's going on here? Oh, this is a partition. Yes, you're bonded. So the side is actually sliding. Yes. No, I would say the I'll go with bonding. It won't make a difference for this simulation, but I will stick with that for now. Same with this side. Bonded. Did I do it for both sides? Did I? No, just the inside, yeah. I'll do the inside and keep it bonded. Sliding, 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 sliding. Cool. Sliding. What is going on there? No, we're good. Sliding. So there's some contact here. No contact. What is this? This is bonded. Sliding in the middle there. Yep, cool. Same thing here. Bonded, bonded. This should all be no contact. Bonded. Same with the side. I think I'm good now. I think I have everything redefined again. Yeah, okay. And then up here, only you have to be bonded. What's going on here? Oh, you're bonded too. Same with this, you're bonded. Bonded, bonded, cool. What is this? What is this? I don't. You should be sliding. Don't know why. That's kind of new, but okay. I feel like that was different from last time, but no problem. So you're bonded. Right. Okay. Yeah. Should be good. Oh wait, no, you're bonded. Right. Totally forgot. Boop. Boop. Okay, so that's bonded. Oh, one more. One more pair over here. Right, okay. So I should be all fully good now. Oh no, bottom here, shoot. There should be the backside here. Yeah. Everything else is sliding. Yeah. Okay. Alright, now we're good. Boom. So with that all good, now I can go back to my joints and remake all of them. Yay, it's so much fun. It's going to make... Alright, so we have... Right, okay, so you're a hinge. Active over here. Actually, I'm going to just... Oh, shoot. I'll just let Altair do what it wants to do. I feel like that might be best. Except the problem is now I can't really see anything. I think there's a way to reduce the scale. You connect to here. Boom, 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 boom. Alright, so I need to hide the rest of these guys, so let me just hide. Alright, let me do these guys now. So you are... This gear boy is locked. You are locked as well. Locked as well. This pin does not need to exist. Locked. Locked. Same here. Is there two yes, there is. Locked. And then locked. Hinge. And then, yeah. That should be everything. So everything else after this, I will just delete. Everything else can be deleted. Yep, alright. So those are all good. So I have everything set up. Did I play rigid group 2? Cool. Alright, so now let me run it again. I might... do I need to define my context again? We'll just see what happens. Oh wait, shape controls. Very, very important. Design space, these two, extrusion. So this makes sure, this is to ensure that like the piece is actually like CNCable. Well, at least on a 3-axis, right? We don't have a 4-axis, right? So we have to make it like at least manufacturable for our machining capabilities. So that's what this shape control is for. So now I guess we just run the motion analysis and see how this goes. If this works, I'm going to freak out, because this is going to be my first successful like full motion modeling, and well, that would be kind of crazy. But I will pause the recording and see how this goes. Okay, so it did not get through everything, but I kind of just noticed this. I don't know why it just started spinning out. There seems to be I don't know. I think it has to do with some contact issue. Oh, whoops. No, I don't want to redefine. Nope. No, I didn't want to rerun that either. Oh my god. No, 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 no. Why am I in wireframe? Hello? Interesting. Alright, weird error there, but it seems I might need to... Something's up here. I think it has to do with my joints. And... Can I scale the joints down? I should probably make it 6061, by the way. I should probably do that for all my joints, actually. But can I like decrease the scale or something here? No. Interesting. I don't know why it went flying like that. Oh boy. Oh, okay. Okay, wait. I see what's going on here. Since it's a rigid group, I don't know why. Do I have to make these locked? I'm just curious. Let me go back and see which one goes flying again. Oh, well, I'll have to let it run, I suppose. Which one goes flying? What the hell, man? Okay, here we go. It's starting to pop out. So it's whoa. Here we go. All right, let's do this guy. All right, so this guy we're going to see if maybe make it a hinge instead. Let's try that. Actually, you know what? In fact, I'm so confident this is actually the issue that I'm gonna do it for all of them. I'm very much confident in my abilities. Alright, well, let's run it again. And it seems to run faster. Oh, that's a good sign. I mean, it's only 0.1 seconds in, but... Ooh, I just have that feeling. One thing I might do is just make this a complete square, and then I'll let it like cut out whatever it wants. I might do that because oh, I think we're good. Oh yeah. Oh wait, no, wait. Never mind, that's just a visual glitch. I think we're good. Yeah. I'm gonna let it do its thing now, because I don't see anything flying, so I'm going to pause it and see where we're at. Alrighty, so I did a lot of things off camera, but basically I just extended this out. You know what? I just realized something. Actually, it won't matter anymore. But basically, I just extended out the plate to make it bigger. So when it makes an optimized part, it might want to add more material on the edges over here. So I just want it to just, you know, make the shape that it wants to based on the stress. So now I'm just going to see what this thing cooks up. Damn. Maybe 5? Let's see how this goes. Yeah, I just want to optimize these parts now. I'm hoping it works out because the hinges that I defined seem to be working. Yeah, so that's kind of what I also did off camera. Well, like, I didn't really record it. Result envelope von Mises stress. Perfect. Alright, nice. So, sure enough, yes, alright. None of this should be reaching yield, which does make sense here. Yes, okay. So the stress that's being applied is actually making sense, which is good. So that's nice. Let's just optimize this now. I want to see what it cooks up. Ooh, okay. Increase minimum thickness. All right. Let's go 0.01. Alright, let's see what this cooks up. It's probably going to take a bit longer. I mean, I did limit the motion to 2 seconds, so shouldn't take too long. I just want to do some rough optimization first, and then I'll do like the full analysis with like, you know, like that kind of thing. I just want to see what it cooks up right now to see if everything went right. I mean, that analysis looked good, so I just want to see if it translates to a good optimization. What I'm expecting is material to be here, 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 not much here, here, all of these joints here, and then it might just get rid. It might just get rid of this one because no. Not actually sure, you know. I'll just see. That's my prediction though. It might like it might just accidentally skip a few of these connections, even though I tried to define it as a connection. It might just not want to connect to it because there's barely any stress in some areas, like here and here, because I think it just transfers to the connection over here. We'll see. It's all yap until I see it for myself, right? So I guess I'll just wait till this finishes. Alright, so it just finished, and sure enough, yeah, it cooked. Definitely cooked. Yeah, I expected something like this, and that's actually very good. Yeah, I'm actually very excited right now because that like, you know, stressfully makes sense, you know, like based on the stresses and stuff, that actually makes sense. Now it's not like fully done yet because again, it needs to run with better, I set like the minimum thickness and stuff. I kind of like BS'd it to just see how it look, but this is a really good start, and this is something that I could machine, like an X-carve. With the X-carve I could definitely do this. I just have to fit this with polynerbs or something and then figure it out from there. But yeah, this is pretty good. I like how it's like a similar shape, but okay, so what I need to do now, where is this guy? I'm gonna go back to you, and I'm going to reanalyze. Oh, you gotta be kidding me. I have to do a remotion. Oh, man, really? Okay, a remotion analysis will be conducted. And then I'm going to analyze I'm going to just go through everything. It's going to take a while, but I'm going to go through the proper channels and actually do the proper analysis and stuff. But this is good because it's actually working. So that's good to know. But yeah, this is probably going to take me to like 6 or something to run through all of it. So I'll come back to you when I go through everything. Okay, well, it finished, and well, the results look really good. Yeah. Yep. All of this actually makes sense. So this is actually pretty nice. Yeah, it actually generated what I wanted it to. So, I mean, for the most part, it's pretty good. Yeah, exactly, yeah. Damn, this thing's good. Boy, it's good. Yeah. Oh, that's so cool. Well, that is the ideal cut out, I guess. So I'm going to keep this guy. Well, I do need to fit polynerbs, but first I'm gonna isolate. Oh yes, I love cutouts. This guy is going to have to, I'll increase the thickness of this guy, but damn, this is good. I have optimized. Oh my god, I'm so good. Oh, I just want to take a freaking screenshot of this. This is so cool. Or just took a screenshot of the whole thing. Good enough. I want to send this. I'm going to send this off to Oh, that is so freaking cool. So that means I just do the same thing for this is, oh, why did it do the whole thing? Okay, whatever. Oh, that is so cool. I guess I can do the same one and run it overnight. Okay, so hold on. Wait, actually, I will reanalyze with this guy now. Once I run the motion for this. It's so freaking cool. Oh, that is so cool. You know what? That's actually my first successful optimization. Well, I'm gonna reanalyze this now. Ooh. Alright, I did the analysis for this side, and sure enough, yeah, that makes a lot of sense for where the stress is. Yeah, because twisting this way, so it wants to twist, right? This entire plate wants to twist, and yeah, I totally get this. So, we're just going to run the analysis. It's gonna take off a lot, actually. Might come out similar to this. We'll see. I'm gonna run this guy now on this boy. 20% run. Probably gonna take a while. Actually, this is a lot smaller of a part, so I might be able to finish this before. We shall see. Well, I'm back from robotics, and well, looks like this thing cooked, and oh, well, sort of did. It's basically telling me that it doesn't need any mass here, which I guess makes sense, but I'll add that back later. But yeah, this looks pretty good. So now I have 2 optimized pieces, and this guy too. Nice. Oh, this looks pretty cool. I do not need to do the other side because, well, there's not much going on there. I can just manually draw it out and stuff, but here it does make sense, so yeah. So I guess we're good here. So I'm gonna fit these. I think you just fit polynerves and then just work on it from there. So if I isolate this guy and just, this was the original, and then I wanted to clear more off, so I do like this a lot better now. So okay, but I suppose I can just start fitting this. I might just do it. Oh, I think it's cooking on that. Yep. Alright, well, we have a part now. Actually, I don't want to do that. I think you just wrap it. Or primitive? Okay, I'll figure this out in a bit.